Thank you for a great talk. As an open-minded skeptic. So you mentioned your fondness for the scientific method, but there's a very key but subtle difference between a scientific study and a statistical study. A scientific study has to include a falsifiable theory of how this works. Do you think that that's an unnecessary assumption and science should expand beyond it? Or do you think that these experiments actually do have some sort of a theory?
Well, that's a good point. And first of all, I don't think that all science requires a theory. No one knew till recently how aspirin worked. No one knew till recently, and they probably still don't know, how high temperature superconductivity worked. There's lots. Newton didn't know how gravity worked. We still don't. I mean, it's supposed to happen on the basis of gravitational particles, gravitons, that no one's ever detected. Lots of phenomena can be recognized as phenomena without a theory. However, I do have a theory. I didn't go into the theory today because I was mostly talking about the phenomena. I have a theory of morphic fields and morphic resonance, which I put forward in my first two books, A New Science of Life and The Presence of the Past. And when I did that, people said, OK, you've got this theory, where's the evidence? Now I concentrate on evidence. People say, OK, here's the evidence, where's the theory? Well, there is a theory, and I think the theory of morphic fields of social groups, for example, makes some predictions. Telepathy should occur between people you know well much more than people you don't. For example, it should be independent of distance. It makes a number of predictions which these experiments test and so far support. And then there are other theories that some people have. Quantum theories of telepathy, quantum entanglement theories, those make certain predictions too, which are being tested. So there's not just one theory, there are several. So I think this is a truly valid field of science. It's based on experiments, data, theories, predictions, tests. I think it meets all the criteria. Far better, actually, than many orthodox areas of science like superstring theory, which makes no testable predictions, or multi-universe theories in cosmology, which postulate quadrillions of unobserved universes for which there's not a shred of evidence. You can say that kind of thing and hold down prestigious chairs in leading universities. So one has to be aware of double standards about this kind of thing.
Thanks.